Hello everyone again. In this session we're going to talk about the tokenomics of the internet computer, which are appearing in the sodium network. The token everyone is talking about is ICP, which was previously called DFN. ICP is primarily a governance token that can be used in the management of the blockchain network created by the Internet Computer Protocol, which is where the letters come from. When the network launches, there will be just over 469 million of these tokens in existence. They are distributed among 4 main cohorts. The first cohort is 500 plus financial contributors, which are made up of those participating in the February 2017 seed round and the later 2018 strategic and pre-sale fundraisers. The pre-sale price, summer 2018, was 4 Swiss francs and 17 cents, or about $4.50. Of course, many things have moved forward since 2018. The second cohort is the 150 plus team contributors, made up of the 120 current full-time team members and others who have contributed over time. The third is 50,000 plus airdrop participants who participated in the airdrop we ran in 2018 and successfully passed KYC. And finally, there's the DFINITY Foundation itself, which holds tokens in an endowment that it uses to fund operations. But what role do ICP tokens play within the broader token ecosystem on the internet computer, and how might they be used? The internet computer actually has 2 native tokens, ICP and also cycles, which are used as fuel for computation. Additionally, every canister can create its own token if it wishes, which shares its identity. A canister can hold balances of any token and can send tokens to other canisters as part of function calls. On the internet computer, tokens can be used for anything, from loyalty rewards through payments, the securitization of assets, and the governance of open internet services. Let's look at how ICP tokens, in particular, can be used in more detail. You can do 2 things with ICP tokens. Firstly, by locking them inside the network nervous system, the algorithmic in-protocol governance system that manages the network, you can create neurons, which can vote on proposals and earn voting rewards, also paid in ICP. Secondly, you can transform ICP tokens into cycles, a kind of stablecoin used as fuel for computation by canisters. When you create a neuron, its voting power, and the rewards you receive from the network nervous system when your neuron votes, start off by being proportional to the number of ICP tokens you locked inside. So for example, all things being equal, a neuron that locks up 200 tokens will have twice the voting power and receive twice the rewards for voting as a neuron that locks up 100 tokens. Depending on your neuron's configuration, a maximum voting reward is available each month. The network nervous system tracks the proportion of votes your neuron participates in and pays you a pro rata share of that maximum reward. Luckily, you can configure your neuron to mostly vote automatically by following other neurons you trust, so it's possible to receive the maximum available reward without doing too much work. Some other factors affect your neuron's voting power too, and the rewards you receive. A neuron behaves a bit like a time deposit bank account, where you can ask to withdraw your money at any time, but it is always given to you after a delay. Essentially, to withdraw ICP tokens locked inside one of your neurons, you must dissolve it. Dissolving takes time, but you can start and stop the process of dissolving a neuron whenever you like. The minimum time remaining before a neuron can completely dissolve and release its locked tokens is known as the dissolve delay, and this falls while a neuron is being dissolved. The dissolve delay is configurable by a dial in your neuron's online management interface. The longer the dissolve delay you set, the greater your neuron's voting power and the greater the voting rewards you will receive, because this encourages you to vote with a longer-term view on driving the success of the network. You can increase the dissolve delay anytime you like. However, the dissolve delay can only be reduced by putting the neuron into dissolve mode. You can think of this being similar to a kitchen timer, where the dial can be twisted clockwise to increase the countdown, but the countdown can only occur through the passage of time. In order for your neuron to participate in voting, the current dissolve delay must be set at between 6 months and 8 years. Personally, I plan to twist all my dissolve dials right the way around to 8 years to maximize my voting power and rewards, as this is a long-term project. The final way neurons increase their voting power and voting rewards is by growing older. The age of a neuron is the time that has elapsed since it was last placed in dissolve mode. Financial contributors to the Internet Computer Project will receive their ICP tokens locked in neurons that have a generous pre-existing age, and will be able to choose between quickly dissolving their neurons to obtain their ICP tokens or configuring longer dissolve periods so they can participate in voting and earn rewards. The network nervous system's payment of voting rewards to neuron holders is inflationary. But let's look at the other way ICP tokens can be used. The other use for ICP tokens is that you can convert them into cycles. The conversion of ICP tokens to cycles occurs at a variable rate, which is constantly configured by the network nervous system in response to external markets, such that burning approximately 1 Swiss francs worth of ICP, which is about the same as $1, will always create 1 trillion cycles, which we refer to as a T. Software canisters that live on the Internet Computer blockchain must be charged with cycles, which are used to power computations and memory management, and are burned in the process. Over time, more and more cycles will be burned by computation. Since cycles can only be created from ICP tokens, effectively over time, more and more ICP tokens will be burned by computation and disappear. This guarantees that so long as computations are running on the Internet Computer, someone somewhere must be buying ICP tokens as a means to create the cycles that power them. When ICP tokens are converted into cycles and burned by computation, that's deflationary, as it reduces the supply. The value of cycles will stay approximately constant, which ensures that the cost of computation remains stable and predictable and allows them to be used as a store of value, for example, within DeFi applications. The value of cycles stays stable for 2 reasons. Firstly, the network nervous system creates a firm ceiling on their price because it will always create 1 trillion in exchange for approximately 1 Swiss francs worth of ICP. Secondly, if there is ever a surplus of cycles on financial exchanges, say, and the price there falls, users will then purchase those cheaper surplus cycles for use as fuel, leading to them all eventually being burned by computation, such that future cycles will have to be created by converting ICP, which returns the price to its usual ceiling. The Internet Computer's use of computation to produce a stable value for cycles is potentially revolutionary, Holders of cycle tokens receive a guarantee that, so long as the internet computer is running, eventually all surplus cycles will be burned and the value of their cycles will return to its usual peg. This works in stark contrast to the stablecoins of today, where such tokens are either collateralized by assets held in trust by custodians acting as issuers and redeemers, or their values are stabilized using elaborate schemes that depend on assumptions about the volatility of crypto assets held as collateral, which in both cases makes them difficult to trust. The power of cycles underscores that the internet computer stands ready to facilitate DeFi just as much as it will help developers create the hyperscale internet services of tomorrow. The last thing I want to mention is open internet services and their governance tokens. We hope open internet services will eventually provide alternatives right the way across today's closed, monopolistic, big tech ecosystem, and we will see open versions of services such as YouTube, LinkedIn, Salesforce, and Facebook. That is why we are developing LinkedUp and CanCan, LinkedIn and TikTok clones respectively, as sample apps. Open internet services will be built from autonomous code that is controlled and managed by open tokenized governance systems, which function similarly to the network nervous system. Tokenized governance systems for open internet services are coming soon and will generate their own token, which is to be used in voting and could potentially receive a distribution of value created by the autonomous system. What's exciting is that each governance system shall contain its own decentralized financial exchange, where their governance token can be traded for cycles. With this financing mechanism, we hope that talented teams of developers and entrepreneurs all around the world will find ways of extending the fabric of the internet by creating a new breed of open internet services. Thanks again, and bye for now.